Hi there. Welcome to this practice set on key traits of quadratics. Please give this video a thumbs up if you find it helpful. I thought it was getting dark outside and now I'm hearing thunder. If you find it helpful, subscribe for more math help, ask a question or drop a comment below, and check out some of the other videos that we have on the channel. Now, this was a long-ish lesson because this tends to be a challenging topic. So rather than rush through it and rush through some examples and definitions, the video does approach it in a couple of different ways. I hope that you're clicking here from there to see how well you're getting this. So pause the video, work these problems on your own, then come back and check your work. We're going to work through each of these with their graphs. So I'll see you in a bit. Right. Now, what I did for each of these was I went into Desmos myself and graphed each of these so that we could see what we're looking at. And most people are actually visual learners, which means that we do well when we can see the representation rather than just staring at a function. If you don't have access to a graphing utility, then the way you have to go about doing this is you have to find that vertex on your own. I referenced this in the video that there is a formula for that. I'll also do a shorter video showing you how to find the vertex of a parabola. And then factor. You'd have to do that for your positive and negatives. But if you have access, then that is far and away the easiest way to do it. These first ones are asking you to find where they are increasing and decreasing. So I'm going to start by just highlighting, and there's no real rhyme or reason to this, but I'm just going to use orange, okay? And I'll try to be consistent on each page, but I can't guarantee I'll be consistent from page to page because I can't remember that much. But on this slide anyway, I'm highlighting the decreasing interval in green and the increasing interval, decreasing interval in orange and the increasing interval in green. I am so sorry. I do that all the time because I'm looking at the green or I'm like a step ahead and my mouth just can't keep up. Okay, so decreasing is in orange, increasing is in green. And that's probably your first step towards really understanding what we're looking for. If my students can do that, then I know that they understand the definition of what it means to be decreasing or increasing. And if they're still getting the wrong answer, we're talking about like a notation or how do I represent what I know in the right way. And that can be like a lot of different things that could cause an issue with the representation. So in this one, the decreasing interval, so if we look at where we are, remember we're looking at that x coordinate, all right? And what I did in Desmos before I screenshot this was I went and made sure I clicked on the vertex so we could see that x coordinate clearly. In that first one, it is decreasing when x is less than -2, meaning it's decreasing over here, okay, to the left. So that's like our chunk that is in orange. Over here, it is decreasing when x is greater than 3, meaning to the right of the 3. In increasing, okay, increasing on this one is to the right of the -2. So this would be when x is greater than -2. Over here, it is increasing when it's to the left of the 3, meaning x is less than 3. And let me just specify that this is decreasing, increasing, decreasing, increasing. And so be careful when you're looking at how questions are posited to you. You might have like blanks you need to fill in. Sometimes you might go from left to right across the graph because we do tend to read from left to right, which in this one you would do decreasing then increasing. This one you might be more comfortable doing increasing then decreasing, just because that's the direction your eye might wander. To be clear, anything you submit to your teacher, make sure that you have it clearly labeled. This is what is increasing. This is what is decreasing. If it's wrong, your teacher can help you out, okay, and help you get it fixed. But if it's not labeled, then it might be right, it might be wrong, and nobody knows and nobody can help you. So like label everything, highlight, use all the visual tools that you have in your toolbox. All right, we'll do the same thing over here. So again, noticing where it's changing over. It's changing over on that X coordinate. So we've got an X coordinate of -4 in that first one and an X coordinate of 3. This time, let's do purple. We'll do, well, that's not purple. There we go. Purple is increasing. So looking at, I don't know if the audio is picking up the thunder. So increasing means it's going up from left to right. So it goes up like that. On this one, increasing means it, again, it's heading up from left to right. And let's do decreasing in red. So this would be heading down and heading down. So if you feel like you're getting that, like if somebody showed you a graph and you in a highlighter, gave you some highlighters and you could highlight it, then you're getting the definition. You're like, that I can do. Like, it's just, I got to put these numbers and these less than, greater than. If you are having issues with less than and greater than, please check out some of my videos where I go through inequalities and I go really in depth. So if you're an Algebra 2 student and you're struggling with that, check out, it's probably either under pre-algebra or algebra 1. It might be under both, but scroll through those playlists, do a little search on the channel for inequalities to go back and get that refresher. You might say, well, I'm in algebra 2, why should I have to go back to pre-algebra? Well, I mean, if you're having an issue with something, go back and get that instruction on it. You're not alone. All right, so using I'm going to write in the highlighter here. So for increasing on this one, it is to the left of the -4, and try not to make boundaries that aren't there. Okay, so sometimes students will stop at the x-axis or they'll stop here, like they'll just kind of stop in places where there's no reason to stop there. So this would be x is less than -4. Over on this one, this is our increasing over here, and that would be to the right of the 3, so x is greater than 3. For decreasing, that would be the right-hand side over here, so that's greater than the -4, so x is greater than -4. On this one, we're dealing with the less than side, so we get decreasing, x is less than 3. And again, I've mentioned this in the video, I might have mentioned it on the last slide. Please try to not look for patterns that are not going to carry you out of quadratics. So I have seen so many students do stuff like, well, when the parabola opens down, then increasing is on the left and decreasing is on the right. And when a parabola opens up, then decreasing is on the left and increasing is on the right. That's true, but one, that is a really random thing to try to hold in your head. And it's not going to work as soon as you're dealing with some graph that's not a parabola. So we really want to make sure that we are working with definitions that are going to go past quadratics and parabolas, because we will do that in polynomials. We'll be going increasing, decreasing, all kinds of stuff. And the same thing holds with positive and negative. Okay, so don't say, well, when the parabola looks like this, then, and you're trying to memorize where to put stuff in like a little fill in the blank. The definition of positive means it is above the x-axis. So I'm going to go and use orange here for the positive. So the definition means above the x-axis, and that is never, ever, ever going to change. Okay, never going to change. And it will work for quadratics. It'll work for other things as well. And then we'll do negative in green. Negative will always mean below the x-axis. Okay, that is what it will always mean. Now, doing the intervals out. In this, now I'm going to actually do something. In both of these, the negative interval is the middle interval. And I think the middle interval might be the easier of the two for most students to get. So we're going to kind of look and see where are those intervals bounded. So on this one, it's bounded by a -7 on the left and a -1 on the right. That's where those intercepts are. So this is my negative. So I'm going to start by writing negative, and I know it is negative when x is between -7 and -1. Now, this one did something kind of weird, and I probably could have tinkered with Desmos to get it to fix it, but it's got those points looking like they're almost out of order. So if you count the lines, this is 1, 2, 3, 4, 5. It's got the 2, 0 kind of right in the right spot, but the 3, 0, it didn't have space to put it like anywhere. And for whatever reason, Desmos put the label for the 3, 0 almost to the left of the label for the 2, 0. So just be aware of that. But the important piece of that is that you've got like the 2 and the 3, and your graph is negative in between them. So 2 is less than x is less than 3. Now, if you do it that way, then it might make the positive a little bit easier. So the positive, we're dealing with stuff to the left of the -7. And so left of -7 would mean x is less than -7, or to the right of the -1. So x is greater than -1. Over here, positive would be to the left. Sorry about that. Positive is to the left of the 2, so x is less than 2. Or over here, which is to the right of the 3, x is greater than. And here's where, like, if you want to remember, it's like it's that part. It's like everything to the right. Okay, so or x is greater than 3. Well, let's take a peek. Maybe the next one, it did not advance. Let's try again. There we go. Okay, and these ones, I don't know why I didn't flip any of these over. I'll look at my problem set. And indeed, I did not have any of these flipped over. So that's like poor problem writing on my part. That's just, I just didn't do it. All right, well, let's do positive in blue. Okay. So positive is above the x-axis, and we'll do negative in yellow. So negative is below. Okay, and let's go ahead and do negative. So looking again at like this space here between those 2 points, that's where it's negative. And so that would be -3 is less than x is less than 4. Over here, it's between 0 and 3, and that I did do on purpose. So that is 0 is less than x is less than 3, because zeros tend to throw students off. Just tend to throw it like, what? I can't have a 0? Yeah, yes, you can. 0 is fine. Okay, this is a number. So again, we're looking at those x coordinates. So reminder, we're looking at the x's, always, always, always looking at the x's. All right, looking at positive. So positive is to the left of the -3. So that would be x is less than -3, or it is to the right of the 4, so that would be greater than 4. Over here, it is positive to the left of the 0, so x is less than 0, or to the right of the 3, x is greater than 3. Now, just because I did not flip any of these over, okay? if you had one flipped over, okay, it would work the exact same way, except this would be your positive and these would be your two negatives. So your negatives would have two different chunks to them and the positive would have one. If you are trying to memorize patterns that are not grounded in anything, you're trying to memorize, like, if it's shaped like this, then it looks like this, you will continue to struggle with that. If you go and study the definitions, positive means it is above the x-axis, negative means it's below the x-axis, it really should not be a problem, because they would all work the same way. All right. So for number 9, this was state all the key points. So the key points are the y-intercept, the x-intercepts, or like you might have more than one, and the vertex. Okay, those are our key points. In this one, my y-intercept is the point 0.08, and the x-coordinate of the y-intercept will always be 0. This one has two x-intercepts, and they are at 2, 0, and 4, 0. And the vertex is the point 3, -1. And when we get to applications, so I haven't recorded it at this time, but I will, so my likely is up by the time you watch this, maybe not. But applications, when you're doing word problems, almost always, not 100% of the time, because sometimes it can ask you just evaluate a function, but if it asks you a question, it's asking for one of those points. So it might be asking you for like probably this number, or this number, or this number, or either one of those. It depends on the question that's being asked. So sometimes you might be looking for the x-coordinate of the vertex. Sometimes you might be looking for the y-coordinate of the vertex. But that puts you at about 5 questions. So if you're given an application problem, there's like maybe 5 different questions that somebody could ask, typically, that you would have to find, and it would be one of those key points. And for the last one, state all the key points and all the key intervals for that. So it's like, let's summarize everything. So we are going to be stating the y-intercept. We're going to be stating the x-intercepts, the vertex, where it is increasing, where it is decreasing, where it is positive, and where it is negative. The only thing that's not being asked in this is domain and range, and I felt like this was already going to be like a 40-minute lesson and a 20-minute homework set, or practice set, without tackling domain and range in there. So, just kind of smaller chunks. All right, so for the y-intercept, that would be that point right there. We are told that is the point 0, 12. We have 2 x-intercepts, and they are the points -6, 0 and -2, 0. And make sure, if you did not label these on yours, that you go back and label them. That's a 0 right there. And the vertex is down here at -4, -4. Increasing means it is going up from left to right. So this is my increasing, and it is increasing to the right of the vertex. Remember to use the x coordinate. So the x coordinate there is -4, and so it is increasing when x is greater than -4. Now, if you do enough of these, you probably realize, well, it's decreasing then when x is less than -4, and you would be right. So if I go grab a different color highlighter, here is my decreasing right there, and that is to the left of the -4. Now for positive is wherever it is above the x-axis. So for that, we end up looking at those x-intercepts, and it is positive when x is less than or to the left of the -6, or when it is to the right of the -2. So we'll have x is less than -6 or x is greater than -2. It is negative when we are in between the two. And so it is negative when -6 is less than x is less than -2. So that's pretty much everything except for domain and range, which I will cover in a separate video, much shorter video because it won't cover nearly as much. But I hope this helped. I hope going over these examples, hearing them explained out, looking at the highlighting, if you did not do well on it, that you were able to go back and check your work. Please check out some of the other videos that we have on the channel, as well as some of the Desmos videos that can demonstrate how to do this. Like and subscribe if this lesson and this practice set were helpful. I know it was really long, but I hope it was helpful. Drop a comment or a question to engage, especially if you'd like me to do a separate one with like the parabolas flipped over, because just didn't do that. And check out many of the other videos and playlists on the channel. I hope to see you in a future lesson.